Watkins Westminster, or Wem Westminster, Watkins Electric Music. So this is, we'll just have a look at the front first, just hone in. So this is a push-pull amp, 10 watts. We've got volume, bass, treble with the on-off switch there. Very simple amp, very nice looking, in good condition for its age. Not sure about the exact date, but it's obviously somewhere around early mid 70s. So look at the back. Nothing to see on the back, I'm afraid, except the old Wem plate there, and you can see the plastic's still on that from when it was new. CW, I'd imagine that's Charlie Watkins. That was the guy that founded this company. There is a date on there. It starts with 7/3, so maybe that is 1973. Don't know on that one. So let's turn it back round and we will plug it in. Let's have a look. Yes, and as you can see, it also needs the plug redoing on that. I think we'll have the top off that and make sure the ground is in place, and then we'll deal with it later as long as it's grounded. We'll come back to it when we've got a little bit more time. Meantime, we'll focus on getting this amp up and running. Top drawer, 13 amp fuse in it, no surprise there, but the ground is in place. I don't like working on things that don't have a ground, especially when they should have a ground. But anyway, enough of me waffling. Let's go, let's get it plugged in. So you can see I've already switched it on, the pilot lights come on there. Let's turn it flat out so we can wait for it to warm up. Now this amp, the output tubes are ECL82s, and it's got 112AX7. So you can hear, we'll just put that there, hear that this amp is quite noisy. You can also hear when all the traffic stopped roaring by that it needs some capacitors. Now the controls are turned down, or the volume is, and it's also got a bit of a hum, although, oh dear, now I had a bit of a read up online about these, and there was a guy, his website's called oldamps.com, and he serviced one of these, and he said all the coupling caps were leaking. Also, they're supposed to be biased very high. So let's have a look what speaker it's got in it. Ta-da! A Fane, a 12-inch speaker, which looks absolutely monstrous in there, doesn't it, really? It's like they got the speaker and just built the amp around it. Very dusty in there. Now these Fane speakers, you either love them or you hate them, and the jury's still out with me. I never liked them years ago, but then I've always been a bit of a Celestian mester. It's also got Mullard tubes in it. Let's pin that on there, see if we can, yes. Now we've got some light in there. Now we can have a look. So the coupling caps in these were, from what I read, are only rated at 250 volts. Let's whip one of these Mullards out, and I don't think they've ever been out of there before. There we go, ECL82. I think the American number for that is, it's 6BM8. 6BM8. Someone correct me in the comments if that's wrong, or put in the comments if that's right. 6BM8, I'm sure it is. But anyway, and these have got a code on there. We need to look that up, don't we? Just to see, because we can get a date off those as well. So it's a 4-date code now. I can't remember now. That to me says that's Blackburn B. I know that for a fact. You're not going to see that on there. This camera's not great close up. B for Blackburn, and I would guess that's 74 on those. Let's see if the other one's the same. You can see they're a bit, if we look there, you can see they've had a bit of heat over the years. Probably still good though. Let's try the next one. Let's remove that. They're very tight in the sockets, and that one again is that the same date code? Yes, it is. B4E4. B is Blackburn. I know that. And I think the code above is the type of tube that it is. I need to, I read up on all that the other day, and I've done that much stuff since. I'm struggling to remember now. But we'll check the website. There's a Mullard ECC83 or 12AX7. Well, that's been stamped upside down. Blackburn 6, Blackburn 76, first week maybe. I'll check. So yes, so the tubes, we need to test those, don't we, in the tube tester, see if they're 3-pulsious or not. So this cap here is 50 plus 50 plus 50, which is a bit strange, because really 50 would be 50 plus 50 would be enough. One for the node 1 and node 2 for that'd be for the screens, node 2, and then the dominators only have a 32 microfarad for the rest of the preamp section, which on this is only 2 stages. So peering inside, as you can see, it's a PC board extravaganza, but then all the Wems are. You can see this is the output transformer here, and you can see we've got, just going to get a pointer because we don't know if that cap's discharged, do we? We've got the Zabel network on here, as they're often called. So we've got that. We need to test that capacitor, make sure it's good. And we've got these smaller capacitors here. That's the cathode bypass capacitor on the bias resistor. Not very big bias resistor, is it, that? But then these tubes only draw 8 watts if they're at 100%. And there's the switch. Now that some of that humming could be caused by that on-off switch, because when you get AC close to DC, it does cause problems. So we'll have to have a look at that. You can see the power transformer is a reasonable size. So yeah, it looks all good in here. It's reasonably clean. There's a bit of dust floating around. It's got a good speaker in there. Again, if you're into Fane speakers, that would be a result. It's 16 ohms, the speaker. Right, what we need to do now is get the chassis out and see how much wire we got on this. Yes, plenty, so I can just snip those with the pliers, with the cutters rather. Trying to get this chassis out, and you can see these screws here, sorry, these nuts here, which are holding this chassis in. And I did start off with a socket and ratchet, but which I could have got those two out. And we'll have the spring washer off there, thank you very much. But there's no getting a ratchet into those. You can see them. If we just hone in with the light, you can see them up the top there, and the other one is, you can see, we go in there at the top, just between the transformer and the cap. So right at the top there. So we won't be getting those out. Let's just move that back. Very easy, unless this goes on. Yes, it does, just. That's a result. That's definitely a result. They're very rusty as well, so we need to put some oil on these when we put them back. But they have come off okay. Now, can we get the spring washer? Yes, because we need those. Otherwise it'll be coming loose when we put it back together. But that one, I'm afraid, is going to be more difficult to get out. So I need to go off and find something to extend this socket with. And there we are, a trusty extension. So we should be able to get in now. There. Flag on there, rusty. There we go. I don't think I'm going to be able to get that washer, so I'm going to gamble on it falling, and knowing my luck, it'll fall into that speaker. So I'm going to just cover my options with that, and I'm just going to add that there in the hope it bounces off. Oh. They've just gone straight down onto the into the bottom there. Let's try it this way. There's also a bolt there which is stopping things for the handle. It isn't helping one iota, so we're above that. Ah, there we go. So it'll only come out one way. Right, I've got it on the bench, and I've got it stood on these pieces of wood, and I've also got this these cleaning things underneath just to stop it scratching that plate, because we don't want to scratch it to bits. So we can have a bit of a look now. So let's look at this cathode resistor. You can see being put down onto the board there. It's had a bit of heat on there, you can see. And it's also a bit weedy, I think, so we'll be changing him. Let's have a look at this big capacitor, and indeed it's pi, 50/50 plus 50, made by Pi, August 74, the 8th week. Does that say, or the 3rd week? I can't quite see around the back there. You might be able to see clearer than me on the camera. So that's the chap we need to remove, because, as I said, this thing is, whoops, camera, is because this thing is noisy, and that's one of the reasons why. So what I'm going to do now is I'm going to connect this up to a speaker, and then we're going to do some testing just to see what the condition of these caps are. And although this board's face down, I can do that because I can get the meter onto the pins underneath these tubes pretty easily. But first of all, let's test these Mullard tubes. Right, so we've got the tube in, 5E1, and test is 8 and 2, although it doesn't say which one's the triode and which is the pentode, but that's 8. Not bad. I should get up to 75 once it's been running the amp and it's got toasty. Well, that one's even better, that side. So that's a good tube. as far as emissions go anyway. Remember, the testing on this is limited. Right, I've got the other one in. This one looks to have had a bit of heat by the state of the glass, so we will be going with 8 again. And that one's not so good. Still thereabouts, but it's not as good as the other. So these tubes are not a good match. So that tells me possibly we could have some leaking coupling capacitors that have made that valve a little tired, or it just could be age, but it's creeping up there. It'll probably get to 70. So let's try it on the other side. Oh, again, very good. But we don't know which side's which. That's the thing in this, but this tube tester doesn't tell you that. Very strange. Right, let's remove him. Now we need to go to 9E1, and the tests are now 3 and 8, and that is for this Mullard 12X7 ECC83, which we're going to put in there. Excuse me with the camera, because I'm trying to hold the camera and do this at the same time because of where we've got this tube tester. Now, you've not seen any filming in this area before, but you'll be seeing a lot more, and all will be revealed once the lighting's in. This is going to be a new test bench, but more on that later. Well, that's gone to 70, so that's good. Let's try the other side. He's good. A little bit more on that one, so slight imbalance on there, but not a huge problem. In fact, not a problem at all, really. So there we go. So the tubes are good. One's a little down, one of the ECL82s, but all in all, they should be fine in this amp. Right, I'm going to check the bias on this, and I've just remembered that I can, on here I've just spotted I can do it off these 3 terminals here. Now, I can't measure plate, well, I could measure plate to cathode, start fishing around under there, but there is an easier way of doing that. So if we just ground this meter, and you can see the meter on there. So the red is center tap, and you can see on there we've got 292 volts. If we look, this is the plate of one side, 288, and this is the plate of the other side, 288, 287, 286. It is a slight difference there, and that's what's making me wonder, it only very slight, if there's a bit of leakage on those caps. But if we say 287, now if we measure across the cathode resistor or the bypass cap, whichever, we've got 18.89. so let's just say 18.9. so if we take, so we've got 287, we know that's the plate voltage, because with cathode bias you don't measure plate to ground, you measure plate to cathode on the valve, and as it's a bit awkward to get to those pins on there, so what you do is 287, and all you do is take away that 19 volts that we got on there, and you're left with 268 plate to cathode, plate to cathode. Let me just check that again, make sure I am right. Yeah, 18.8, 18.989, we'll call that 19 volts. We're only looking for a rough guide. So now we've got to switch off and measure that resistor. And whilst it, you know, you can look on the schematic and say, oh, that resistor is whatever it is, you can see it there. We never do that, because if that resistor's been baked, it could have gone high in value. So the resistor is, ouch, caught the tip of my finger on that tube. That made me jump. So what we got there, still going up because of the cap. Wait till it settles. You can't see it on the meter now. I think it's 200 ohms on the schematic. and it's heading that way, isn't it? Yeah. We'll call that 200 ohms when we're looking for something rough. So we know we've got our plate to cathode voltage is 268. Our resist, so we've got that. Now the drop across the resistor is 19 volts, and we have got a 200 ohm resistor, or 200R as I like to use. So what we're going to do now is we're going to take the 19 volts and we're going to divide that by the resistance, which is 200, and that gives us 95 milliamps. Now we're going to take off 5% for the screen, and that gives us 90.25 milliamps there. Now we're going to divide that by 2, because obviously that's 2 tubes and they're running at a whopping 45 milliamps, and if we times that by 268, they're running at 12 watts a piece. And they're only 8 watts dissipation. Dear, somebody got the maths wrong there. It's a wonder they've lasted that long. I think that's just a credit to how tough Mullard tubes are. My days, they're well over. So we need to sort that out as well before we do anything. That's way over what it should be. Right, we're just having a look at this schematic for this Westminster. We're going to start down here, so you can see we've got 245 volts, so that's AC voltage before it's rectified. We times that by 1.414, we get 352.8 volts. That's before the tubes are drawing current. Here you can see we've got 290 volts. That's after the tubes have drawn current. So there's a fair bit of current draw on there, and there's no surprise with those tubes being as hotly biased as they are. So if we carry on up here, you can see we get that goes then through the center tap of the transformer, and that comes out to the plates. Now we don't have a voltage reading there, but we already know what that voltage reading was because we've measured it, and then we've deducted the cathode resistor voltage from that, and that gave us 268 volts. If we look at the 1.5k resistor here, that's going down to the screen, so it's dropped to 260 volts to the screen. So there's technically an 8 volt drop now. Whether that's been measured plate to cathode or plate to ground, I don't know. And then we carry on through there. We've got this 50 microfarad cap smoothing that, and then we've got a 15k resistor there, and then that's going down into the phase inverter plates there, and then this, and then that is, so that's, where's there, so there's 50 microfarad, that's for node 1. There's 50 microfarad for node 2, is that right? Yep. And then where's the 50 microfarad is here, that's the third one, and that's smoothing the phase inverter and the this preamp tube. We've got 2 stages here and here. So that's giving you a rough idea of what's going on there. So there's the 200 ohm cathode resistor, and there's its bypass capacitor, which is also 50 microfarad, which seems to be a running thread in this guitar amp. So we know by these voltages, we can more or less work out from these voltages, really, from what we could see on here, that this amp was built to, you know, to run at 12 watts dissipation. So what is the purpose of that when they're only 8 watts dissipation? Well, maybe they didn't realise. I can't quite believe that. Maybe there's some reason for it, I don't know. Right, before we do anything else, we are going to cut that cathode resistor out, and just jumper in another one, and the reason for that is that while we're running this amp and doing a few tests on it, we're just baking those tubes, and there's just no point in doing that when we can quickly tack in another resistor. So that's what we're going to do next. So we will get the cutters. So that resistor's been baked anyway for the last 50 years, so we won't be using him again. Now you can see, if we just hone in there, you can now see where that resistor has just over the years has just scorched the board a bit there. No big deal. Right, we've got it plugged in. Now let's see what we've got across our resistor. Well, we'll best put it on DC, otherwise it won't work, will it? I'm just going to raise this so you can see the meter clearer. We're getting a bit closer as well. There we go. Now let's see what we've got. 20.44 volts we've got now. So 20 volts will be near enough. 20.5. So now we need to measure across the plate to ground there. 293, take away 20.5, 272.5. That's our voltage, plate to cathode. 272.5, splitting hers there, but never mind. Right, what we need to do now is do the calculations and see if those tubes are thanking us very much for 8 watts dissipation. So we've gone from 200 ohms to 300 ohms. That's my phone, by the way, affecting the signal. So we've got 20.5, that's our drop across the resistor, divided by 298 ohms equals, that's now come out at 68.7 milliamps. Take away 5% for the screens is now 65.3 milliamps. Divide that by 2, because remember that's both tubes. We're now down to 32 milliamps. And if we times that by our 272.5, we are 8.9 watts. This is still over at that. It's still over 8.9 watts. So we need something a little larger than that, don't we? But they will be saying thank you very much, because they won't, you know, they're now running, they're still over 100%, and they'd probably run at that, you know, a watt over. They probably would run at that, but they're Mullard tubes and we're not having it. We're going to make those 8 watts. Right, I've just jumpered the other resistor in there. And just a thing to remember as well, that look how close this is to the transformer. So when you switch this amp off to, you know, change this resistor or whatever you're doing here, remember that if the cap hasn't discharged, these terminals will be live if you lay your hand against it. So put the meter on and check that the voltage has gone out the centre tap, the red wire to ground. Put the meter on, make sure the voltage has gone out of it. Remember the motto, do it right and you won't get a bite. Right, let's move on. It's a 390 ohms this time, but we've only got 381 when we measured it, so it's 9 ohms shy. Right, let's do some maths on that then and see if we've got these tubes now. So 22.5 divided by 381 equals 59 milliamps. That's looking better. 59 milliamps, take away 5% equals 56 milliamps. Divide it by 2 per tube, that's 28 milliamps. And now we're going to times that by 279, 7.8, and that's where we're leaving it. That's fine for those. 7.8, just about spot on, 100%. Some people would take that a little lower, maybe, but let's face it, they've been running for 50 years at 4 watts over, so that's not going to be any problem, is it, running at 7.9 watts? Or are they 7 watts dissipation? Now you've got me thinking that they're 7 watts dissipation. I think they are. Let's just switch off. I think they are. Something in the back of my Wem. I need to look again. I bet everybody's shouting, you're wrong there, they're 7 watts, not 8. And I think you could be right, because that's just 6BM8 ECL82. So this is the RCA receiving tube manual. Let's have a look. Maximum ratings, 7 watts. Duh. Not 8 watts, 7 watts. So they were 5 watts over there. 5 watts they were running over. Oh, that's not far off double, is it, that? Oh dear. My word. That's unbelievable. That it's amazing that they've just not burnt up being run that hot. 5 watts over. So yeah, just suddenly then as I looked at that and said 8 watts, I thought that's not right. 430 ohms I've got in, but it actually measures 423. Some of these resistors are a bit low. I've got an array of cathode resistors. Well, I call them cathode resistors because that's all I ever use them for. 5 watt, 423 ohms. 23.4 divided by 423 equals 55 milliamps. Take away 5% for the screen. We've now got 52.5 milliamps. We divide that by 2, so we've got 26.27 for each tube. And now we times that by 283.2, 7.44. I bet those tubes are breathing a sigh of relief now, aren't they? My word. Right, well, I think we can draw a line at that. 7.4 is fine. They're tiny bit over, but that's neither here nor there now, considering what they were running at. So these tubes were, again, 5 watts over biased. We've got the amp biased properly now, and that needed doing, didn't it? Amazing those tubes have survived that. I can't believe it. They've survived that amount of hammer. Just credit to just how tough those Mullard tubes are, and we should get years out of those now, considering somebody's already got 50 years out of them being thrashed. Makes you wonder how often this amp was actually used, you know, and if it's been stored somewhere for a lot of years. Anyway, that's done. So the next thing we need to check for is grid. In fact, you know, I'm not even going to check for leakage on these capacitors, and I'll tell you why. So the guy, again, going back to this guy from oldamps.com, that's done. I'm going to switch off now. The guy that's serviced one of these on his website, oldamps.com, I'm sure that's what it's called. He was spot on right about the bias being miles out, although he didn't give the dissipation. Basically he said it was burning the tubes up, and well, we can't argue with that, can we? And the board on his, if I remember in the pictures, was burnt as well. So I'm going to go with him on these 250 volt working coupling caps, and I'm going to change the lot. I'm not going to mess about doing any more testing on this. I'm just going to change them, because to be fair, you know, and we may find this is another thing, we may find when we change those that the bias goes down again, because if there's any leakage onto these grids, we may be finding ourselves putting that resistor back up again. Right, let's check a few of these resistors on this board. Let's try and get the camera. So I'm going to start working my way down from this power supply. So we've got a 1.5k drop-in resistor here, which is for the screen. He's a little bit over, but not massive. and he's coming down now because of the capacitor. We'll call him good. 1.5k. So the next one is 15k. That's the drop-in resistor down to the preamp stages. 15k. He's good. 1 meg. We can't get a measurement of him, maybe because he's in circuit, obviously. 1.5k. Yeah, 1.54. Now the plate resistors. I think we'll change the plate resistors. We'll just change them. How many plate resistors have we got? 1, 2, 4. We'll change those. Just have some new ones in. There's a grubby little 1/4 watt 10k resistor there, which indeed does measure 10k, but I think we'll swap him as well. I don't like those. I'm going to put a 1 watt in there. That's probably a grid stopper, but we're only speculating without looking on the schematic. What we got here, is that 47k? Oh, that's good enough. And we've got here 270k, it's 272k, so that's got those in there. That's a plate resistor, that's a plate resistor. We're not bothering with those because we're just going to change them because we don't want those crackling in 3 weeks time when this amp's been run for a while. I don't like carbon comp plate resistors. 447.2, that's spot on the money, that one there. So let's have a look at this. 1 meg grid leak, that'll do. 1 meg grid leak, that's okay. 27k, that's okay. 220k, 220k, 234k. So he's a little out, that one. Equals 234k. We'll make a note of that. So that one's just a little bit out, not far, but it's out. And there's one hiding here, a 220k also hiding. 231k, 232 again. Probably, I mean, it's probably worth noting that they've been close to this heat, or that one certainly has, and that one does look like it's just caught the tail end of that heat a little bit there, so maybe that's why that one's high in value, and it's, I don't know, they're both high, so maybe they're just put in that way. Right, and that's it. That seemed to have, we've got 470k there. We didn't do him, and he's only measuring 25k, so it's obviously because he's in circuit, it can't be that far out. It's in parallel with something else. So so 100k, 1, 2, 3 and 4, there will be plate resistors, but we need to check what's on the phase inverter. Or will it be cathode? No, it's not. We've already looked. It's long tail per fool. Yeah, so that's good. So we just need to check this 400k resistors here. I'm pretty sure they're all plate resistors, so we'll be swapping those. Right, we've got this all back together and we've got it recapped, and let's just hone into here and see how we've done this. So we've got two 47 microfarads there for plate and screen, and we've got a 33 for the preamp stage. Don't need a 50 microfarad for that, it's overkill. Even on the dominators they've only got 33 in there, 32, whatever. We've got 33 in there. Now I've hot glued these all around, hot glued them together, hot glued them to the board, and we've wired the grounds over here with some 18 gauge and gone through there. You can just see over the top there, and that's really the only way to do these, because finding a can that will fit, and I've never seen a can like this, so check that out. And you can see the middle of it is bulging out, and it looks like gumption is beginning to leak from it. So he's all over. You can see him now pretty clear. 50 plus 50 plus 50, 350 working volts, and yeah, 1974 third week. Now if you're going to put these caps in, don't like this, don't stick the super glue on the bottom of the cap. One is it won't seat properly, and two, it might burn through the rubber insulation on the positive on the front there, so that wouldn't be a good idea. My voice is a bit croaky. It's gone midnight now and I'm still in here. We've replaced the cathode bypass capacitor. We've got a nice Vichy in there, 47 microfarad. There's our 430 ohm resistor in there. That green capacitor over there, you can see if we just hone in there, he's 47k. It's getting tired. He's 47 nanofarad, and he was 0.1, not 0.01, sorry, but on the schematic it's 47. So I've changed that, put it back to how it was, but maybe they just stuck that in because they didn't have one at hand at the time. So we've changed the plate resistors, the 4 of those, and I've changed these 220Ks over here because they were a bit out of just not quite right. They were a bit high, so they've been changed, and that is a wrap, I think, and we're ready to run this amplifier up now and give it a listen. 159 volts going on in there. The amp's turned up full. We've got sound, so we'll just let it sit for a minute. Let these caps absorb the juice. Sounding, it's noisy again. So the noise we can hear, that which is the buzzing, I think is this switch here, and it's a common problem with these on-off switches that are incorporated into the pots. They tend to be very noisy. So let's just go up a bit more. There we go, got 246 on there, 183 on the Variac, and a bit more, 200 volts plus. There we go, that'll do us for full voltage. You can see very noisy. Mr. Mullard here, this preamp tube, I didn't is microphonic, as you can see. Did notice that before when we was testing. So you can see we've got about 309 volts there. That's plate to ground though, not plate to cathode. You can hear these wires. Yes, I think that's what's causing that, I'm guessing. Although the filament wires leave a lot to be desired. capacitor there, move that away from the switch. Yes, so always a problem with these amps. Now it is turned up flat out, so obviously as we turn that down, it won't, at a normal level, home use, whatever, it won't be a huge deal, but if you were using this cranked, then that's pretty loud. Now I would, in an ideal world, like to remove that and put a switch on this amp, but of course that means drilling holes in it, and that's probably not a good idea in this amp, given its age and it's in such good condition. You know, if it was a bit beat up and well gigged, I'd be tempted to do that, but it's not pleasant, that noise. And you can see if I get the mains lead now, put it near the tube, so clearly this that's going on there, I think, that's causing that humming. This filament arrangement has a centre tap to ground, so you know, it's not like we could say, oh, there's no virtual centre tap on it. Just have to mull that one over, won't we, and have a think. So what we're going to do now is I'm going to check the bias, just make sure it's still okay, because of course we changed a lot of components, and then what we're going to do after that, we're going to have a think about this, have a look at him, he's a little bit noisy. And I think that about wraps it up on this one. But the other thing I want to do on this amp, in comes Pink, by the way, into the workshop. We've not seen her for a while. The other thing I want to do on this amp is a turns ratio test, and the reason for that is, on the output transformer, turns ratio test. The reason for that is these tubes were biased at 12 watts, and we had quite a lot less plate voltage than we've got now, because as we reduce the bias, the plate voltage increases, as you know. So the turns ratio is going to be nothing. The effective load resistance is what I want to find out on these tubes with this kind of voltage that we've got. Well, plate to cathode, because remember we deduct the screen resistor off there, the drop across the screen resistor. With that kind of voltage, we're looking at somewhere around 11k effective load resistance for these tubes, but at 12 watts and at a lower plate voltage, we're looking at something much different, something more around 8k. So either the effective load resistance was miles out before we changed the bias, or it's miles out now. And what I'm trying to find out is a reason why they biased these valves so high. What even made them think that these valves would stand that current? And that's that current, because it's so noisy. It's anything you touch, look, that really is microphonic. What made them think that they could run these tubes so hot, and what was the reason for it? Because they must have known when they built this. There's no way that you wouldn't, I mean, you can't be that far out with the bias, can you? 5 watts, that's just 5 watts over. That's been done for a reason. So has it been done to match the effective load resistance? Has it been done because someone thinks it will sound better? Have they done it to just simply get more volume out of it? Who knows? But I do want to do that turns ratio test, so I'm going to tattle down and have a go at that now. Right, so we're going to do this turns ratio test, and how this works basically is we need a variac to do this, and you need 2 meters. So on the primary side of the output transformer, we're going to feed a voltage into the through the each side of the output transformer through the primary side. We're not using the centre tap, we're using either side. That's why I've took the tubes out. It's the wires that connect to the plates on the tubes. And we need a plug. You need a plug top, or a plug with bare wires, and you need to connect that to the primary, either side of the transformer, as I've said, onto the plates. And then the other meter is connected to the speaker, the secondary, what would be connected to the speaker, the secondary on the output transformer. And I'm going to insert a voltage into the primary. When the secondary reaches 1 volt, we will have our turns ratio. So the meter on the left is the one that's measuring the 1 volt. The meter on the right is the one that will give us our turns ratio. So we go up on the variac, and you can see we've already reached 1 volt there. I just need to go down till we get to there, a bit more. There we go, 1 volt, 20.7. So our turns ratio is 20.7 to 1 on there. So we need to write that down. We'll switch off. Next thing is we need to dismantle all of this. So rule number 1 is you've got a plug top here. You've got a plug that plugs in with bare wires. Just pull the camera back. Here with him on. Now put this away straight away when you've done this, and the reason is that if you leave this lying around and you've got a few things, you know, other plugs and things, and you pick this up by mistake thinking it's something else and plug it in, the wires are bare on the other end. Now we've only had 21 volts on that, but when you plug that into the wall it'll have 240 volts, or if you're in the States it'll have 110. So always roll up and put it away. It's the safest thing to do. That way no confusion, and you know, always try to be safe when you're doing this sort of thing. The worst thing about that is that you could, you know, a child could plug that in if it's left lying around. So it's a big no-no. Always put those away. The only child I have in here is Pink, which is why I put it away. Because knowing my luck, I plug it in and Pink would be on the other end of chewing it, wouldn't you, Pink? She's not talking to me today, and she won't be talking to me for a few days because I'm afraid it's flea treatment time, and when I put the flea treatment on her, the ones that go at the back of the neck, well, she falls out with me for 2 or 3 days. But it has to be done. Anyway, I digress. Let's get back onto this turns ratio. Right, so we've got 20.7 to 1, so we're going to take 20.7 and we're going to times it by 20.7, so we could, or square it, whichever way you want to look at it. That leaves us with 428.49. Now we've got a 16 ohm speaker, so we're assuming this is a 16 ohms tapping. So if we times that by 16, we get 6,855. So 6.8k, that would be rounded off to. So that's the primary of that transformer is 6.8k. Right, so we're doing a bit of adding up and maths and whatnot. So when this amp was biased at 12 watts, we'd got 268 volts plate to cathode. So we know that the turns ratio test has given us a 6.8k primary at 16 ohms. Remember, we've got 16 ohm speaker. So I did some maths to find out how close that 12 watts was to that 6.8k. So we had a 268 volts plate to cathode voltage. So if we square that, it comes out at 71,824. Divide it by 12, that comes out at 5.985k, which is rounded up to 6k. With these tubes at 12 watts, we've got the maths for that has come out at 6k. So this is 6.8k. Bear with me on this. So to find out what impedance this tap-in would be, because obviously we've worked from what we've got to get the 16 ohms tap-in, we've worked off the turns ratio. Now we're not working off that now. We're working off the plate voltage and the dissipation that these tubes were set at, which is why we've now got 6k. So if we take the 6k that we've got from the plate voltage and the dissipation of these tubes, and we divide that by 428.49, which was the result from our turns ratio test, we get 14 ohms. So with these tubes in here at 12 watts and at that plate voltage, that comes out at 14 ohms with a 16 ohms speaker, which is fine because the speaker is higher than the tapping on the transformer. So really they could have biased this at 11 watts and still come out roughly level on that, 10.5 watts actually. If they'd have biased these tubes at 10.5 watts, that would have been exactly 16 ohms tapping with a 16 ohm speaker. But then again, in test conditions, what voltages they actually had at the time, whatever, these tubes were in a different condition then, blah blah blah. You can go on forevermore. You know, we're only looking for some kind of average. However, we've now got these tubes biased at 7.2 watts, so 7 watts really. These are dissipated at now, we've got 272, so not much more plate voltage. If we square that, now comes out at 73,984. Divide that by our 7.2, that gives us 10,275 or 10.275k. So this time we take our 10,275 and we divide that by our turns ratio, 428.49. That comes out at 23.9 R, which really rounded off is 24 ohms with a 16 ohm speaker. So this tapping is now 24 ohms with a 16 ohm speaker, which is the speaker's too low, so it's drawing, theoretically it's drawing more current. It's always a no-no to have a speaker lower than the tapping. So for instance, you wouldn't put an 8 ohm speaker on a 16 ohms tapping. However, you can do it the other way around. So that now means that we've got the wrong tubes, or we've got the wrong wrong output transformer. So why did they bias these tubes at 12 watts? Well, I think we've got the answer to that now, haven't we? The answer to that is simple. Someone ordered these transformers and they had a barrel load of these tubes, and then they realised that they weren't going to match up. But somebody has probably realised that they could get away with running these tubes a lot hotter, and so they upped the bias. Maybe they upped it just to see what they could get away with, I don't know, but or they already know that they could up the bias on them, and they got away with it, and it worked. But the difference nowadays is these tubes are scarce. They're also quite expensive. You know, what would you pay for a new old stock pair of Mullard ECL 82s? A lot of money. So where does that leave us now? Options. Well, we could up these a little bit more and get some kind of balance. That's one option we could do. So where would the bias point be on these tubes, the dissipation? So let's just say let's bias them at 9 watts. So the plate voltage would probably be about 270 volts. We're really splitting hairs with this plate voltage, but 270 volts. So 270 volts squared is 72,900 divided by 9, that's 9 watts. That now comes out at 8.1k. If we divide that by 428.49, we now get 18.9 ohms with a 16 ohm speaker. So the speaker is still lower than the tapping. The tapping will become 18.9. So roughly that's 19 ohms with a 16 ohm speaker. We've now got 3 ohms difference there. You know, some of you guys out there probably have more experience. You might be saying, well, that's near enough, leave it at that. So that is an option. I wouldn't want to push those tubes any more than that, really. I just think that 2 watts over is more than enough on those, given that they're only 7 watts anyway. If you're talking about an EL84 at 12 watts, and a lot of people push them to 13, well, I've seen them pushed a lot more than that. So we've just said we've either got the wrong tubes or the wrong output transformer. Well, we don't want to be changing the output transformer. What about changing the tubes? Well, the problem is that these sockets are soldered into the board, which means that we'd have to find some tubes that dissipated at 9 watts, were a triode and a pentode. The mu on the pentode, the mu on the triode would have to really be the same, and they'd have to be the same pin out, and they'd have to be dissipate 9 watts. Well, we're not going to do that because I've already had a look. However, I have found a tube. In fact, I own a tube. In fact, I own a boatload of tubes. We open it and we look in there. Look at those. Yeah, there's loads of them. These tubes are, let's try and get one out so we can get that one out. These tubes are 6F5P. These are a Russian tube, 6F5P. This is kind of the equivalent, or they say it's an equivalent to an ECL85. So here's the tube. Look at it in more detail. There is a date on it, and that's the 11th month of 1974. So could we put a pair of those tubes into this amp and bias, and obviously the 9 watts dissipation, but could we bias those tubes then at 10 watts? Well, yes, we could. We know a watt wouldn't be the end of the world. But the problem is the pin out's different on them. So I've worked out what we'd have to do for the actual pin out, and I've got that on here for the actual socket. I would have to cut 5 traces and rewire them. Pins 4 and 5 are the same, they're the filaments. Pin 6 and pin 7 are the same. So pin 9 would have to be cut, pin 8 would, and pins 3, pins 2 and pins 1. So 5. So let's just say we bias these at 10 watts. These, and we put these 6F5Ps, we put them in, we got them wired up. We can do that. It's doable. Anything's doable if you want to do it. Really, it's doable. We dissipate them at 10 watts. So we'd have a plate voltage of roughly around 270 volts. So 270 squared, 72,900. Divide that by 10. That comes out at 7.29k. Divide that by the 428.49 of the turns ratio, comes out at 17 ohms with a 16 ohm speaker. So the optimum point for the plate dissipation on this, for 16 ohms on this transformer, is 10.5 watts. 10.5 watts would give us an exact match. But we're close there. We're only within an ohm. So we could buy a set of those 6F5Ps at 10 watts. So this amp then would have more wattage. It would be louder technically. Now some people out there will be saying, well, you know, why are you going to all this trouble? What this is just a small, you know, amp, whatever. There'll be some people out there saying, well, you should have left it as it was, but it's burning up the tubes, and we've already explained why I've changed that. Some people will be saying, well, just leave it, it'll be right, it's only a practice amp. Well, it will till it burns out the output transformer. Now I'm not saying it will burn out the output transformer, but it could do. And they've obviously overbiased these tubes because they thought it might do also, and they didn't want it coming back with, you know, failed transformers. But why am I doing this? Well, it's entertainment for one thing. We're learning. We're all learning. Not even me going along really doing this. You know, it's all a learning curve. We're pushing the boundaries of this amp. We've got tubes that I've bought from. Well, I bought these from the Ukraine. Those tubes, and I've tried to buy a lot of tubes from the Ukraine over the years, and without getting too much into politics for obvious reasons. It's putting bread on their table. So we're providing entertainment. And some of you, I know some of you enjoy these in-depth projects, and that's really why we're doing it. You know, some people wouldn't be bothering with this. While I'm doing this, I'm not earning any money, but you know, not at repairing amps anyway. And I have to be careful when I'm doing a lot of this, because if I'm not careful, I get a backlog of repairs. I've been able to put time in on this because I'm waiting for parts for other amplifiers. Do we put in the 6F5Ps? The mu of the Triode is identical to the mu of these, so we're not losing nothing on the phase inverter, so that's good. And we can push these a watt and a half. They'll take it. The Russian tubes, they'll take it. And the other thing is, if we put these in this amp and they only last a year or 2 years, there's a box full of them. There's loads more of them on. There's millions of them on the, you know, online being sold, because there's just millions of these knocking around. There's not millions of these ECL82s left. Also, that means we can take this beautiful pair of Mullard ECL82s and put them in something that they should go in. So there we go, conundrums. Do I just up these a little bit and compromise and end the video? And, you know, we put it back together, do a sound test and end the video? Or do I carry this video on and, you know, and this video's already gone on a long time, carry this video on and we put these tubes in? I'm tempted to do it because it's a great project. I had a bit of a read up again about the guy I was talking about who'd done this had serviced one of these, and it's actually oldamps.weebly.com. I'll leave a link in the description for it, you can have a read. And one of the things is a question he puts in there. I don't know why Wem would have overbiased these tubes, question mark. Well, I think we do now, don't we? So I think I'm going to make this part 1. And I'm going to put this up and get some more opinions on this and see what people say. I would like to try and put those tubes in this amp. There's going to be some purists out there that are going to be against this, but this isn't a massively valuable amp. It's not like I'm butchering a Fender, you know, a 1950s Fender amplifier. It's a small practice amp at the end of the day. So that'll do it for this one. So thanks for watching, and you all take care, and I'll see you all in another video. Bye bye for now.